Metal injection molding actually combines the best of two worlds. We have the free-forming capabilities of injection molding and the mechanical properties of the metals. There is 4 steps in the metal injection molding process. The first step is getting the feedstock, and by feedstock I mean the plastic mixed with the metal powders. The metal powders can be from very low alloyed materials to stainless steel to more exotic alloys and even titanium. Afterwards, the material is used in a classic injection molding process where we into a mold inject the plastic with metal powders to get a green body out of it. One of the important things here is to handle the part with care because it's a bit more brittle than normally. And secondly, to have already in the design phase thought of where to put the inlet and ejection zones. Comparable to regular plastic molding, the main difference is that we need to inject the feedstock quite rapidly because of the heat transfer of the metal powders inside. After injection molding, we go into a debinding step, and the purpose of this step is to remove as much of the plastic binder as possible before going into the sintering step. We sinter at a temperature just below the melting temperature of the metals and still are able to retain the shape. The shrinkage in the components here happens both during the molding of the part, but mostly and primarily during the sintering step. The metal powders shrink from 16.7% up to 22%, depending on which alloy you're using. We aim at having a net shape process and having the parts directly finished and ready for packaging and control or inspection just after the sintering step. Typical properties of components produced in the MIM process are very comparable to route material. It is possible to optimize the properties of the material during the sintering step by adding different gases, raising and lowering the temperature, and playing around with the cooling rates. Imagine you have this very nicely shaped 3D printed part and you need to make it in tens of thousands. This is really where the process shines because this is a possibility to manufacture these very highly complex components in a relatively simple process. If you have the material as a powder, it is possible to process it in MIM.